Hello students, in chapter 4, that is pair of straight lines. In this lecture, we are going to cover the concept of angle between lines. Consider the general equation ax square plus 2hxy plus by square is equal to 0. Now, suppose we know the slope of a given line. Then, the angle which that line makes with either the x-axis or the y-axis can be found out, because slope is nothing but the tan value of theta, tan of the angle made by that line with the positive x-axis. So from that we can find out theta that is there. Now in this equation ax square plus 2hxy plus by square is equal to 0. Suppose b is 0. Then we say that one of the lines is nothing but the y-axis. This we had learned in the theory of the previous lecture that is there. Now using the slope of the other line, we can find the angle between them. Now henceforth, we've discussed, that is we assume that b is not equal to 0. So we have to define the slopes of both the lines. So if the slopes of both the lines are m1 and m2, then we know that the product of the slopes is given by m1 into m2, which is a upon b. Now suppose the lines are perpendicular to each other. This is a very important concept. It is going to help you in solving sums. Suppose the lines are perpendicular to each other, then we know that the product of the slopes of perpendicular lines is nothing but minus 1. So we say that m1 m2 is equal to minus 1. Now what is m1 m2? m1 m2 is nothing but a upon b. So we say that a upon b is minus 1, or a is equal to minus b, or a plus b is equal to 0. This is what you have to keep in mind. So for perpendicular lines, a plus b is equal to 0. Now suppose the lines are not perpendicular. See, perpendicular lines make angle of 90 degree with each other. Suppose the lines are not perpendicular, then we find the acute angle between them by using the next theorem to follow that is there. So theorem 4.4. The acute angle between the lines represented by ax square plus 2hxy plus by square is given as tan theta is equal to 2 root of h square minus ab upon a plus b. Now in the proof, suppose, now remember, proof can come in the exam. The theorem can come to be proved in the exam, and needless to say, this particular formula is quite important. Now suppose m1 and m2 are the slopes of the lines. We know that the sum of the slopes is minus 2h upon b, and the product of the slopes is a upon b. We also know this formula which we learned in our last lecture. We used this formula in the last lecture, one of the sums. That is m1 minus m2 the whole square is equal to m1 plus m2 the whole square minus 4m1 m2. So we substitute the values for m1 plus m2 and m1 m2. Thus we get this particular term that is there. Then squaring etc. and solving further and equalizing the denominator, we get this term. The denominators are common now, so we write it under the common denominator, that is b square. Taking 4 common, we are getting 4 into h square minus ab upon b square. Now this is nothing but m1 minus m2 the whole square. So taking square root on both the sides, we get m1 minus m2 is equal to plus or minus 2 root of h square minus ab upon b. Now to help you visualize the situation, this figure is given to you. That is, as you can see over here, the lines pass through the origin. And in general, the equation of a line passing through the origin is y is equal to mx. So the equation of one of the lines is y is equal to m1x, and the other line it is y is equal to m2x. Now suppose theta is the angle between the lines. Then we have tan theta is equal to m1 minus m2 upon 1 plus m1 m2. Remember, this is a formula which we had learned last year when we learned about straight lines. This formula was there. Now in this formula, in the mod sign, now we substitute the values for m1 minus m2 which we found just now, and In the denominator, we have 1 plus a upon b. A upon b is the value for m1, m2. Then 1 plus a upon b becomes a plus b upon b after equalizing the denominator. And then b gets cancelled on both the sides. I mean in the numerator and the denominator. And thus we get mod of 2 root of h square minus ab upon a plus b. So tan theta is nothing but mod of 2 root of h square minus ab upon a plus b for a pair of lines, the acute angle between the pair of lines. Okay, so this is what you have to keep in mind now. Now suppose the lines are coincident. That is, suppose the lines are parallel to each other. See, we know the condition that if the lines are perpendicular, then we have a plus b is equal to 0. Suppose the lines are parallel or if they are coincident, that is one and the same, then their slopes are equal. That is m1 is equal to m2, or we say that m1 minus m2 is equal to 0, or we know the value for m1 minus m2 from the previous slide. It is 2 root of h square minus ab upon b, which is 0, or ultimately h square minus ab is equal to 0. So this is the condition for coincident lines. So remember both the conditions which we learned, that is the condition for perpendicular lines as well as the condition for coincident lines. Now that we are thorough with the theory, we can see what sort of sums are coming in the exercise that is there. So we start with exercise 4.2. The question is, show that the lines represented by 3x square minus 4xy minus 3y square are perpendicular to each other. Now what is the condition for perpendicular lines? Yes, it is a plus b is equal to 0. So comparing the given equation with the general equation ax square plus 2hxy plus by square is equal to 0, we get a as 3, 2h as minus 4, and therefore h is minus 2 and b is minus 3. Now here there is a common mistake that you can make during the exam when you are in a big hurry to complete the paper. That is, over here when you calculate 2h and on the other hand suppose you have to use h in the sums, you may run along and use 2h in the sums. Don't make that mistake. Do remember to calculate h from 2h. I hope you are understanding me. So here a plus b comes out as 3 minus 3, which is 0. So we say that the lines are perpendicular to each other. The second question, show that the lines represented by x square plus 6xy plus 9y square is equal to 0 are coincident. The condition for coincident lines? Yes, h square minus ab should be 0. So just like we did in the previous sum, we calculate a, 2h and therefore h and b. And we calculate the value for h square minus ab. As you can see, it comes out as 0. And so we say that the lines are coincident. The next sum, find the value of k if the lines represented by kx square plus 4xy minus 4y square is equal to 0 are perpendicular to each other. That means here perpendicular lines are given to us. Their equation is given. And so we say a as k. From the equation we see that a is k, 2h is 4, that means h is 2 and b is minus 4. So since the lines are perpendicular, we have a plus b as 0, or this value k minus 4 is 0, or k comes out as 4. Again, it is such an easy sum that they can give it to you as an MCQ question or as a question for 2 marks. This can be done as an assignment. I have provided the answer to you, and similarly this sum as well can be done as assignment. So moving on, the next question here. Find the measure of the acute angle between the lines represented by, there are many questions which are given here. This may be the most important question of this exercise because almost every year a question is asked of this sort. The first equation is 3x square minus 4 root 3xy plus 3y square is equal to 0. So these are a pair of lines. We have to find the measure of the acute angle between the lines. So here, comparing the equation with the general equation, that is ax square plus 2h xy plus by square is equal to 0, we get a as 3, 2hs minus 4 root 3 So h comes out as minus 2 root 3 and b is 3. Now suppose theta is the angle between the lines. Then by the formula which we studied just now, we have tan theta is equal to 2 root of h square minus ab upon a plus b in the mod sign. And therefore, we substitute all the values over here. And thus we get this particular value. And from here, we get this value. That is 1 upon root 3. So tan theta turns out to be 1 upon root 3. Now 1 upon root 3 is nothing but tan 30. Remember, we are taking the positive values outside the mod sign. So tan 30. So we say that theta is equal to 30 degree. Thus we get the answer. So learn this formula for tan theta thoroughly by heart. Keep it in your mind so that you can solve the sums readily. The next question as well we'll do over here. That is 4x square plus 5xy plus y square is equal to 0. Now we calculate a, h and b, and then we put the formula for tan theta. Suppose theta is the angle between the lines. And thus over here it turns out that tan theta comes out to be this particular value. Simplifying this, you can see how it has been simplified. In the next step, we equalize the denominator under the root sign. So we get this value. And then by bringing the values outside the root sign, we get this particular value. 2 gets cancelled. So we get tan theta as 3 upon 5. Now we really do not know which value of theta gives us the angle of tan as 3 upon 5. So we simply write that theta is equal to tan inverse of 3 upon 5. Now the next sum, the third question, you can try it out as assignment in the same manner as the first and second question have been done. The fourth question is given as a square minus 3b square into x square plus 8ab xy plus b square minus 3a square into y square. Again, these are a pair of lines and we are supposed to find the acute angle between them. Looking at the equation, there is no need to take tension because it has to be solved in exactly the same manner as we solved the first three sums which are there. Okay, so over here, again by comparing the given equation with ax square plus 2h xy plus by square is equal to 0. Observe that here in the general equation, we have used capital letters a, h and b so as not to get confused between the general equation and the given equation. So we get a as a square minus 3b square, 2h as 8ab, so h becomes 4ab, and b as b square minus 3a square. Now, it will be very confusing if you put the direct formula, that is if you use all these values directly in tan theta formula. So we calculate the terms separately. That is, first let us go through what is h square minus ab. So h square minus ab becomes 4ab the whole square minus a square minus 3b square into b square minus 3a square. Now observe how it has been solved. So here in the next step, 4ab the whole square is written as 16a square b square minus the two brackets have been multiplied now. So we have a square into b square minus 3a square minus 3b square into b square minus 3a square. So the first term now remains the same. In the second term, the bracket you can observe a square has been multiplied with the first bracket, that is a bracket which is given there, and similarly minus 3b square is also multiplied with the same bracket, so that we get these terms. In the next step, the similar terms are added, that is a square b square plus 9a square b square. We get 10a square b square. Rest of the terms remain the same. Then in the next step, the bracket is open because of the minus sign. The signs after the bracket change, as you can see over here. Then we get this particular term. Now here we observe that 3 is common. 3 is a factor for all the three terms, so we take 3 common outside the bracket. Now inside the bracket we have a raised to 4 plus 2a square b square plus b raised to 4. Using the formula a plus b the whole square, we get 3 into a square plus b square the whole square. Okay, so h square minus ab becomes this particular term. So root of h square minus ab becomes root 3 into a square plus b square. We also need a plus b in our formula. So we calculate a plus b by adding the relevant terms. We see that in the two brackets, a square minus 3a square gives us minus 2a square. Similarly, minus 3b square plus b square gives us minus 2b square. We take minus 2 common. So in the bracket we get a square plus b square. Now that we have got these values, we can use them in the formula for tan theta. So in tan theta, we substitute these values. We cancel out 2 and 2 from the numerator and denominator. Similarly, we also cancel out a square plus b square. And thus we get tan theta as mod of minus root 3. Remember, theta is acute. So tan theta is going to be positive. So tan theta is equal to root 3, which is nothing but tan 60. And thus theta turns out as 60 degree. So now in this particular lecture, we are going to cover only so much of exercise 4.2. You can practice this easily in a single day, so that the remaining 3 sums we can cover in the next lecture to follow. So as usual, keep practicing, keep safe and healthy, do subscribe and like the channel. So we meet in the next lecture now.